seal-in logic, and we're going to use a conveyor example. Okay, this is where we stopped in the previous video, and we had duplicated the classic start-stop circuit, and we're using it to operate a motor. It's not really a motor. What you see here are 3 bits in memory of the controller. This I:0.0/0 points to a bit in memory. This I:0.0/1 points to a bit in memory, and O:0.0/0 points to a bit in memory. So we're using the state of bits in memory to perform our logic. Now it just so happens that these 2 bits are dominated by the field devices connected to terminal 0 and terminal 1 of that input module, or those inputs on the controller. This bit, which will be reflected by whatever's attached to output 0 of the I/O module or the controller, is dominated by the logic. Of our 3 memory locations here, these 2 are dominated by the I/O scan, and this one is dominated by the logic. Now you can toggle this bit on or off. If I toggle it on right now, you're going to see that it goes right back off. Well, actually, I forgot I had this seal-in contact here. So you see that I could toggle this bit, and of course it stays on because it's sealed in with this instruction. In this case, these are push buttons. These are most likely push buttons attached to these inputs. And in fact, on your simulator, they are push buttons. This is just a light. This controls a light. But in reality, it's a motor starter. A motor starter is a type of relay or contactor that typically has 4 sets of contacts on it. 3 of them are high voltage, high current for 3-phase motors, and then 1 of them is an auxiliary contact that you can use for something else. So if you energize the coil on this motor starter, 4 contacts close. 3 of them close 3-phase voltage to a 3-phase motor, and the 4th one is probably not used, but it's there as an auxiliary contact if you want to turn something else on. So it could be a motor starter, and by the way, they don't call them motor relays, they call them motor starters because they also have motor overloads on them. Too much current is drawn, it will interrupt the circuit and drop out the starter or the coil. Think of anything that uses a motor, like fans, and in particular conveyors. Conveyors are very, very easy to visualize, so we're going to use conveyors a lot in our examples. And this is from the lab manual, this conveyor system right here. And you have 3 conveyors. The first one is gravity. You can see the rollers. They don't have much of an angle. It doesn't take much for these cartons to roll down and hit the leading edge of the first conveyor. So you have a gravity conveyor, and then you have 2 motorized conveyors. In some cases, these motorized conveyors, 1 conveyor and 2 conveyor, will be controlled by the circuit that we've shown. And it's most likely going to be an actual electrical circuit where these 2 are push buttons. That's a relay coil or contactor or motor starter coil, and this is the aux contact that seals it in. If you want to pretend that this is a hardwired electrical diagram, that's okay because they are relatively identical. The only thing that varies a little bit is this would be a normally closed push button. We do have a normally closed push button attached to input 0, and a normally closed push button has continuity when it's not pushed. So in order for us to use that in the logic, right now we have a normally closed push button, and that means that its bit memory is on. So we want true if on. We want true if the normally closed is closed, if it has true continuity. So that's a little bit of a variation between a hardwired circuit and one done in relay ladder logic in a program. Okay, We've also got 4 photo eyes. Initially, we may not use all the components that you see here, but here's the general idea. This carton comes up by gravity, it rolls up and it hits the leading edge of this conveyor, but it's not going to go on the conveyor unless the conveyor is energized. If the conveyor is energized, then this carton will be pulled onto the conveyor and it'll block the optical path of 1 PE. If this is wired as an input to your controller, then the controller knows, or you could say you know through the logic, that something's blocking this photo eye. Something's interrupted the optical path. And of course the conveyor is running, so it's going to pull the carton all the way onto the conveyor. Judging by the width or length, if you like, of that carton, it looks like it'll block both photo eyes at some point. In other words, it'll come on, it'll block this optical path, and then it'll block this optical path. This one will clear. If it keeps going, this one will clear. Judging by the length of it, if it keeps traveling, after it's cleared both of these, it will block this optical path. It'll interrupt this optical path, and at that point, at any point actually, you can start and stop the conveyor. So when it blocks this photo eye, you could stop the conveyor if that's what you wanted. Or when it hits this one, which means that it's all the way onto the conveyor, and this carton trailing behind is now up against the edge of the conveyor, you could stop the conveyor then. Or when the carton travels all the way and interrupts 3 PE optical path, you could stop the conveyor then. If 2 conveyor is running and you turn on 1 conveyor, then the carton, wherever it's at, eventually will block this. Or let's say this carton right here is up here and it's blocked this photo eye. And you turn on 1 conveyor, it feeds it onto this conveyor, and when it blocks this photo eye, now both of them are blocked simultaneously, and in the logic then you can know where that carton's at. It's leaving 1 conveyor and being pulled onto 2 conveyor. Now you know it's leaving and being pulled on because you got both of these energized, because you control them with your logic. So remember, if you've turned on this output to run this motor and you've turned on this output to run this motor, then you know the 2 conveyors are running. And if the 2 photo eyes are blocked at the same time, then either you've got a carton that just broke this one, and somehow there's a different carton, the trailing edge of which is broken this. Now the way you would tell the difference is that if there's nothing blocking either, this carton is blocking 3 and then it's blocking 4, then you can use logic that remembers to remember that nothing was blocking 4 when 3 was blocked. Therefore, both conveyors are running, and now something's blocking both, and you know there's a carton that's passing from 1 conveyor to 2 conveyor, and so forth and so forth. So, I mean, you can just keep on going with this. All manner of logical plans that you could come up with. But controlling conveyors is very highly used out there in the real world. All of these, good-sized stores that you purchase from, like Walmart, Kmart, Myers, Costco, Sam's Club, they all have distribution centers. And these distribution centers, they have deliveries and out shipments. So they will have a truck come in from, let's say, full of Samsung TVs. Well, not all these TVs are going to one store. They're fed out of the truck on a conveyor, just like you see here, probably gravity, comes down, it goes onto 1 conveyor, and it'll make its way into the system, and then the barcode readers read the barcodes on the cartons, big flat screen TVs, and then they're all the same. Let's say they're all the same part number, and it'll send some of them over to section A, some to section B, and then over in those sections, they're packing up a shipment to an individual store. So in the course of the day, you got Samsung TVs going into the truck, parked at door 1, and then you've got something else going to that same store, so it all ends up going to that same spot. Also, Amazon has the same thing. So Amazon has huge distribution centers. FedEx, I've done a lot of engineering for FedEx distribution centers, and UPS is the same, DHL. All of these delivery companies have distribution centers, and it's nothing but hundreds of conveyors, all controlled by a PLC or a PAC. I had you put in this logic right here and then test it. So I'm going to go back to the program, put that logic in, and then I'll be back. Okay, I have the first rung finished, and notice that I changed the address for motor 1, but I forgot to change it here. That's something that I forget quite often. I don't think of it as being used someplace else. And I'm going to add a second rung, and because they look similar, I'm going to, this one's, the focus is on this rung, so Control C, Control V, and I've got another one that looks just like it. And I'll move this one down here. That way the one I'm editing is down here. And this, I'm not editing this rung. You don't see any edit zones in front of here, right? There's no R's here. I'm not editing this rung. I made a copy of it. I did a Control C and then a Control V. And I pasted, I should have probably selected, I'll back up and do that again. Okay, so I put the focus there. Then I said Control C. I should have clicked here and then Control V. Then it put it down there. I mean, I can move these rungs around later, but notice I'm using the same stop button. Then I have Photo I1. So I'll go in here and type in the new memory location. And of course it comes up with the auto describe, and it's 1 PE. And then this is, I'll just delete that one because it'll be easier to just click here, put the focus here, and then click up here, and then put in, and I'm going to show you something. I'm going to drag this over, double click here, backspace 3, enter, and then 2 PE. There's all kinds of ways of doing your editing that may seem a little quicker than others. And then my size fault, I can take and grab that memory location, drag it down to there, and drag it down to there. After a while, once you become accustomed to writing logic, then you become accustomed to shortcuts and faster ways of doing it without interrupting your thinking to consider the tools that you have. So you learn this stuff in steps. First, you have to learn about the data table. You got an online data table or an offline data table. And when you're looking at a program, you're always looking at an offline program. There is no such thing as a online program or project. Now there's online program files and online data table. That's what's in the controller. But if you're looking at something like this, whether it says remote run or offline, you're looking at the offline project. If there isn't one, then you cannot open RSLogix. You have to have an offline project. Just want to keep emphasizing that. But once you learn about the data tables, online, offline, and then you learn about the fact that this is an offline project, but when you're online, then the states of these bits, the online data table is what animates this. Nothing's moving here. You just see these things going on and off. For instance, if I push the stop button right here, if you want to call that animation, but nothing's moving, it's just, it's off, it's on. So you're using the online data table to animate the offline project. We're going to test this. I'm going to swing the conveyor back in here as best I can. You're looking at your manual while you're watching this video. And if you don't have a manual, you should have a manual. In your manual, you see 1 PE and 2 PE and 1 conveyor. And you see that all that we have here is 1 conveyor. Now I got it motor 1, but I could change that to 1 conveyor if that makes you happy. But this is the motor that's controlling 1 conveyor. And here's the 2 photo eyes that are at the entrance of the conveyor, and they are in the order that the carton would block. So if I start this motor, I'll just turn it on. I'm going to use the push button, momentary contact. I'm going to tap it really quick. See? Well, you can still see that it went true, but as fast as you can. I don't know if you saw it that time. Watch the start push button again. Yeah, it flickers. No matter how fast I do it, you see it. So anyway, motor's running, conveyor's running. Now, that doesn't mean there's any cartons, right? So although I have this drawn with 2 cartons, that doesn't mean there's any cartons there. Okay? And that's why we use conveyors, because it's easy to visualize. So there's no cartons right there. And let's say a carton comes along. First thing that's going to happen is if the conveyor is stopped, then the carton will come up against the leading edge or the entrance of the conveyor belt and then just stop there. Then if you turn the conveyor on, the carton starts moving. It gets pulled on by friction, and the first thing it does is breaks 1 PE. Okay, and 1 PE is input 2. So now you see 1 PE is blocked. Now that's a long carton. So guess what? 2 PE is going to be blocked before 1 PE clears and then 2 PE clears. The size fault actually occurred. I'm going to hit the stop push button so we can do that again. With a stop push button, we did that on purpose. Okay, so I'm going to reset the fault, but if both photo eyes are blocked, the fault's going to trigger again, and that's exactly what we want. So I'll turn it back off. Conveyor's running when we push the start push button, but we still have the fault. Got to hit the stop push button to clear it. Now this is the way the logic's supposed to work. Just because I'm fumbling around with it doesn't mean that it doesn't work right. I just need some training as an operator, even though I designed all this. Okay, we use the stop button to stop the conveyor and to reset the fault. So we're making use of one input to do several things. So if I push the start push button, now the conveyor is running. If 1 PE is blocked, clears, and then 2 PE is blocked, clears, there's no size fault. But if 1 PE is blocked and then 2 PE is blocked, watch what happens to the motor. Stops instantly, and the carton sits right there. That's what we want. If the carton's not the right size, in other words, the photo eyes are adjusted, the distance between the optical paths, to pass the smaller carton, but not allow a larger carton to pass. Okay, you could set it up either way. So in this case, you have a size fault, and as long as you have a size fault, you can't run that motor. I can go up and push that start push button all I want, and it's not going to run, right? I can push the stop button, and as long as I hold it down, there's no size fault, right? Because that rung is now false. But if I let go of the stop button, I still have the fault because I have not pulled the carton off the conveyor. So then, in order to reset it, the operator has to go over and pull the carton out, then hit the stop button, and now you can start the conveyor back up again. And now let's look for another carton. So now the second carton was a smaller one. It blocks 1 PE, clears, blocks 2 PE, clears, and on the way it goes. Simple as that. If you want to add some more logic to this conveyor to accommodate some other things and play with for a while, be my guest. Okay, we had a few questions towards the end of this 2-page lab project, and at the point where the logic has been folded, like this, are both 1 PE and 2 PE blocked? Yes, they are. Did your conveyor stop immediately? Yes, it did. Is the red fault light illuminated? Yes. Now you know why we swapped the output addresses around, memory locations, because I wanted the fault to operate the red light, not a green light. Flip the inputs 1 and 2 PE to the opposition. Did the conveyor restart? No, we never want, if something's stopped because of a fault, you don't want it to automatically start again. That's unexpected motion. Now maybe the operator is expecting it. In other words, if the operator walks up, grabs the carton, pulls it out of the 2 photo eyes, if you allow the conveyor to start right then, you could see where that could lead to an accident or injury depending on the situation. And someone else might be standing there not paying any attention when the operator pulled the carton off, and all of a sudden, the conveyor starts up and they were leaning over doing something and their clothing gets caught in it, etc., etc., etc. It is a good thing that the conveyor does not restart when you clear the jam or the rogue carton. when you release the stop button, did the press and release the stop button while the photo eyes were still blocked? Did the red light extinguish? No. Why? The carton's not removed. Is this a good thing? Yes. Why? Forces removal of the rogue carton. Then turn off 1 and 2 PE. Did the conveyor restart? No. Is this a good thing? And again, yes. It's a safety issue. So you always got to be thinking of these things. When you first start doing this kind of programming, you may not be thinking safety. But I'll guarantee you, people that work out in the plant or in the facility, they'll notice unsafe conditions right away, and they'll be surprised. If an operator pulled a carton off and everything started back up, they'd really be surprised. Now, most conveyor systems of any repute sound an alarm or a horn when they're going to start back up. If the operator pulled off the carton, you could have it programmed so a horn sounds for several seconds and then the conveyor starts up. Typically, the operator has to pull off the rogue part or the jam, clear the jam, and then hit a button. Then that sounds the horn. You know how people walk across conveyors. So it sounds the horn for 2, 3, 4, 5 seconds, and then it starts up. So you're warning people that there's motion. You also will notice along conveyors that there is a cable running through eyelets that run to a plunger switch on one end to the other. That's an emergency stop. If you're working on a conveyor and it starts up and your clothing is caught or something, you can reach over, grab the cable, pull on it, and everything comes to a halt. So there's a lot to conveyor systems that don't meet the eye until you start programming them.